So does it become x to the power of 20 equals 3?
It will become log form.
Log 4?
Not log form. So log form. For if it was like x.
Oh, would it be like 3 base x and then like, no, it'd be 3 base 20 and then x.
Let's see. So hang on. It has to be log something. So log. What's the base?
The base is x, right?
X is the power.
Oh, so 3 is the base.
So 3 is the base. Yeah.
And then it'd be 20 equals x.
Yes. Logs are powers, and so it's equal to the power.
Which is 2.73 to 2 decimal. Oh, right, 3 decimal places. 2.7287, sorry.
2.727?
Yeah.
Great. Next one.
Okay. So it'd be log 61 base 5 equals 4x minus 1.
Yeah. Sorry about that.
Right.
Log.
I got x is 0.889. I put it all into the calculator.
Okay. Probably worked. There you go.
Yeah.
2.77. Great. And the long way to do it would be, let's see, would be like add 1 to both sides.
Yeah.
And then divide both sides by 4, or however you'd go about it. And it might be easier to do that with, like, they might force us to do that. We'll see.
Yeah.
All right, this one. Hang on. Before I, yeah. All right, let's do. Well, hang on. Before we do B, that's fine. Fine. Oh, maybe. There might be something slightly different about this one. Yeah. Let's try this one.
Okay. So can that become... Do you have to make both sides log?
Yeah, I like your thinking.
Okay. So would it be log 3? No, the base would be 3.
Uh-huh.
But would it be x then? Oh no, it wouldn't be x, it'd be 2x plus 1.
2 to the x plus 1.
Yeah. Equals x.
Yeah.
And then you do the same for the right side. So it'd be log 2, base 2, sorry, for the log.
Say it again, sorry?
So would it be, it would be log 3 base 2. Would you make, would you get two answers?
This is it. You now need to try to solve it.
Oh, okay.
You could write it another way around, but
Okay.
and so any idea how you go about solving that?
For the power of +1, you need to get rid of the 1, right?
You might not remember, but with log rules, when do you see what's the rule for if you have power to a power?
You add them.
So that's power to a power.
So it's 5, or is it multiplied so it's 6?
Yeah, you multiply them.
Okay.
And so you can write that as the power x plus 1, basically bring it to the front, x plus 1 times that.
Yeah.
Okay. And then what's next?
So would you multiply x plus 1 by everything?
Divide.
So it'd be log 2 base 3 over x plus 1.
2 base 3 equals x over x plus 1.
Yeah.
Yep.
And then on the right hand side, the x cancels out, so it just gives you positive 1.
Nope. So maybe, hold on, maybe I'll regret this, but I'm going to give you a different method because let's just say this will be the method for when you have x on both sides.
Okay.
Log both sides. Just log both sides.
Okay.
You get log 3 to the x equals log 2 to the x plus 1. Any idea what you do next?
Would you do inverse log?
That would get you. That would bring you back to the question. Bring the powers down.
Oh, so you get x on both. Okay, so it'd be. So on the left, would you divide? So it'd be log 3 over x.
It would be x times log 3. Power to a power. Multiply.
Equals x plus 1 log 2. And then you'd multiply, which gives you log x 3x.
So that is x plus 1 log 2. Let's see. Maybe it isn't easier. I would divide both sides. So you're trying to get the x's on one side. So let's say we'll get it on the left. No. Let's expand the brackets. What would you get?
For the right.
Yeah.
You'd get. Well, if you multiply x and log, it would just give you log 2x.
It'd be x log 2.
Okay.
So it's like it's in a bracket. You can't do that.
Add log 2.
Add log 2. Let me think.
And then could you minus x log 2 on both sides, or would that not work?
Yeah, that would work.
Which gives you 2x just 2x log.
Well, let's say x log 3 minus x log 2 equals log 2. Factorize out the x.
Okay. So it'd be log 3 minus log 2.
Yeah. And then
could you divide?
yeah, divide both sides by the bracket.
Which gives you, which gives you log 3 minus log 2 over log 2. Oh no, log 2 over that.
Yeah. And then you could put that in the calculator. Maybe it isn't any easier than the other way. Maybe we should just stick to the other way.
Which gives you 1.7095 to 4 decimal places.
0.95. Yeah, maybe we should just stick to this way. That's it's very, very similar. All right, we'll log both sides when x is on both sides. Do it that way.
Okay.
Yeah, okay, let's try A.
Okay. So would you log both sides first?
Yeah.
Which gives you log 4 and then x plus 2 on one side. And then log 5 x minus 1.
So I just wrote them as the power.
Yep.
Is that what you meant to one side or something? Okay.
And then would you move the power to the left?
Yep.
Which gives you x plus 2 log.
Yeah, and it's the whole thing, so it's in a bracket, x plus 2.
Yeah.
Log
4, would it still be 4?
Yeah.
Equals x minus 1 in brackets log 5.
Well done.
And then do you have to minus? You can't do that, can you?
Expand.
Both sides.
Yep.
So you get, on the left side you get x log 4 plus 2, would it be 2 log 8?
2 log 4.
2 log 4 still, okay. 4 equals x log 5 minus log 5.
Yeah. What is next?
And then you could simplify by bringing x log 5 to the, x log 4 to the right side.
Yeah. X's together, numbers together.
Yeah.
Go on, anyway, you don't have to do it all in one go, whichever way you want.
Okay. I'll do the x's first.
Okay.
So would you minus, right? Minus x log 4 on both sides.
Yep.
Okay.
Call me. Let me see. Let me think about this. Okay. Yep. Go on.
So would x minus x be 0, right?
Don't overthink anything. Just what are you certain of?
5 minus 4 is 1. So it gives you log.
No. Jesus, no. That's like saying the square. That's like sine 5 minus sine 4 is just.
Oh yeah.
It's just sine.
Yeah.
Okay. Hold on. Here's what you're certain of. X log 5 minus log 5 minus x log 4.
Minus, it would just be minus x log 4, right?
Yeah, so like you're certain of that much, yeah?
Yeah.
Yeah, so that's okay, great. Now move numbers together.
Oh, I get it now, because x log 4 is like a separate number, isn't it? It has to be the same to be taken away.
Um,
X.
Not really, but okay.
And then can you plus log 5 on both sides?
Yeah.
Which would give you 2 log 4 plus log 5
Yeah.
equals x log 5 minus x log 4.
Yeah. What's next?
You divide by x log 5. No. Divide by 2 log 4 plus log 5 on both sides.
Factorize out x.
Okay. Which would give you x brackets log 5 minus x log 4.
You factorize out x.
Oh, sorry. Minus log 4.
Yep. And we want x equals.
So can we divide by x on both sides?
We want to get rid of everything that isn't x from the right side.
So we divide by log 5 minus log 4 on both sides.
Correct.
So we want to put that into, can we put that into the calculator on the left side?
What will you put in the calculator? What is the full thing?
You'd put into the calculator 2 log 4 plus log 5 over log 5 minus log 4.
Great.
And that gives you your answer, right?
Yeah.
2 log. Which gives you the three significant figures 19.6.
19.6. Great. 19.6. Okay, I'm happy. Using this substitution. Oh, that's interesting. That's a good one. I like that one. Even though it's right at the very end. Yep. I'm doing this one. Should I? Hang on. Let me think about this. Not just yet. Not just yet. Maybe I'll regret it. We'll see. Next is this one. Any idea how we solve part B?
Okay. Do we want to make it so it's... So would the minus 1 be brought to the left and the x minus 3 be brought to the right?
It's like square root of x minus 3. You can't
Okay.
take it out of the bracket. It's like our sine x minus 3 is being logged.
I don't know what you do then.
My guess is index form.
Okay.
Base power, that stuff.
So you bring log 5 to the right.
Base is 5.
Oh. Okay. So it becomes log.
There's no log.
Oh yeah. So it's for x minus 3. Where does x minus 3 go? The 5 gets brought to the equals on the right. The minus goes on the left.
That's kind of the direction you go in. Don't mind me. This is it. 5 to the minus 1. So it's just the reverse.
Okay.
And then you solve that.
Okay. 5 to the minus 1 is the same as 1 over 5, right?
Yeah.
Okay. And then you add 3 to both sides, so fifth. Add 3. 16 over 5 or 3.2 equals x.
Sounds alright. 3.2. Yep. Question B.
Okay. I got 9.74 equals x.
Nope.
No.
Working out?
So I made it. Would it be 7 to the power of 0.8 equals 5 minus x?
Mm-hmm.
And then I did 7 to the 0.8 first.
Yep.
Okay, 7 to the. That's what I did. 0.8. I got 4.7432, and that's 7, 6. Bunch of numbers.
Okay.
Oh wait, it's because I added 5 to both sides.
Aha.
You minus 5. Yeah.
Here's what I do. 2 mark question. That's the first mark.
Yeah.
And then this is the second mark. And yeah, it was the minus that got you.
Yeah.
Minus is never easy, no matter what. Here you go.
Mhm.
And that's that one. Oh, come on. Okay, let's see. Oops. Okay, you get the idea.
Mhm.
Now. Ah, yes. I said I would do the last one first. It's a pretty good one, strangely. Yes. Any idea about this one?
Okay. Question A, right?
Yep. Do both.
Okay. So would you add 10 to both sides first? Or would you keep it on minus 10? Oh, you can't add 10, can you? Because it's like sine.
Use the substitution. Wherever you have 3 to the x, replace it with a u.
Okay. So we get 9x minus u plus 1. To the power of plus 1.
Ah, I see. I see why this question now. That +1 makes it tricky. I see why that's at the very end. Okay, we'll do it a different way. This one. Use the substitution u equals 5 to the x.
Okay. 5 to the x, right?
Yeah, 5 to the power of x. U is equal to 5
Okay.
to the power of x.
So it'd be 5 to the power of 2x minus 12 brackets u close brackets plus 20 equals 0.
Yeah, and 5 to the 2x, you could also write that as 5x, 5 to the x squared, because it's power to a power. They're being multiplied, power to a power.
Okay. So it'd be brackets 5x squared.
5 to the x squared.
Yeah, 5. Oh, yeah, 5 to the x, sorry. 5 to the x squared. Minus 12. Would it just be 12u?
Yeah.
Plus 20 equals 0.
And so we now have another 5 to the x.
Oh, yeah. So you can replace that as u. So it'd be u squared
Yes. Then you solve that. How do you solve that?
as a quadratic.
Yeah.
I got x is 10 and x is 2.
So technically u is 10, u is 2. We just created u to help us do this difficult question.
Yeah.
So now we bring it back. So u, 5 to the x became u. So now u goes back to being 5 to the x.
Okay.
And now we solve it.
So you could write it out as which one would you use? Does it matter?
You'd solve them separately. So 5 to
Okay.
the x equals 10. How would you solve it?
10 squared.
Write it in log form.
So it'd be log 10. No, log 5 base 10.
5 is the base.
Okay, so log 10 base 5
Yeah.
equals x. And
Yeah.
then you work that out.
Mm-hmm.
Which is 1.430 and a bunch of numbers.
That's it. And
Well, it would be 1.431 if it was just 3 significant figures.
that'd be 3 decimal places. 1.43, three digits, 3
Oh yeah,
sig.
yeah, okay. Yeah.
And next one.
Okay. Other one would be log 5. No, 10. No, 5 log base 5. Log 5. No, log 2 base 5. Sorry.
Great.
Which gives you 0.43. Would the 0 be counted as a figure?
Not if it's at the beginning. So I'd give one more.
There's another 0 after that.
That's fine then, if that's how it works out. Oh, did it round to 4?
Yeah,
4, 3?
it was 6 after that, so it'd be 1.
Right, there we go. So it's a hidden quadratic. That
Yeah.
5 to the x you can replace with a u, and then that one is like squared.
Yeah.
And it's a very common type of question. Let's do B.
Okay. So can we use to the power of x as u again?
Yep.
Okay.
And this time it would be what to the power of x?
4 to the x.
Yeah.
Equals u. So it'll be u squared again. U squared.
Just u. U is equal to 4 to the x.
Not as in like the start of the equation. Would it be
Yeah.
u squared?
E squared, yeah.
Minus 10u plus 16 equals 0. And then you can solve that as a quadratic. I got 4x to the power of x equals 8, or 4 to the power of x equals 2. And you solve that as... So to be... Would the base be 8?
No.
Oh, the 4 would be the base, so it'd be log 8 base 4.
Yeah.
Which gives you 1.5 or 3 over 2. So
wow.
x is 3 over 2. So x. The other one would be it would be log 2 base 4.
Well done.
Which gives you a half.
Great. So x is equal to 1 over 2 or 3 over 2. That's great. And that's the main thing with that one, that's a hidden quadratic.
Yeah.
It seems like this one has something else that's kind of weird about it. Let me just take a quick look. So that one, how else can you write 9 as 3 to the power of something?
Would you need to like you square root it?
Just 9 equals 3 to the power of
2.
Yeah. And so 9 to the x is the same as 3 to the 2 to the x.
Yeah.
Which is the same as 3 to the x to the 2.
Okay.
Yes.
Okay. Yeah.
Yes. This thing here, that's a trick. When do you have powers being added?
When it's multiplied, the logs are multiplied. But powers can only be added if it's multiplication.
Yeah, so that's 3 to the x times 3 to the 1.
Okay.
Yes. And so replace with u, what would it be?
It would be u squared minus u times 3 to the 1 minus 10 equals 0.
And simplify this bit in the middle.
It would give you 3u minus 10.
Yes, that's it. Okay, so there's a little more for that very hardest one, but we have the main thing there.
Yeah.
Those ones.
Probably between a tick and a half, but probably close to the half.
Okay. Yeah, I mean, it is, logs. Okay, there's a special log. We saw this e to the x before. The derivative of e to the x is e to the x.
Yeah.
Log base e, I'll just say anything, equals ln that anything. So it just has a special name. Log to base e. It's the base of natural logarithms. Logarithm naturel in French or something. And so it's ln or ln.
Okay.
You say ln
Okay.
a. Great. Okay. Solve this one. How would we solve the first one?
Would it become log 5 base e equals x?
Yes, this time by default log in your calculators and stuff is like so hang on, so what you're doing is log Yeah, you're this log 5 base e
Yeah.
equals x. Yes, what is log to base e?
Log to base e.
It is called ln.
Oh, so it'd be ln 5.
Yeah, they wanted exact form, and so the answer is exactly ln 5.
Oh, okay.
Yeah. And so, let me see. Okay, let's try A.
Okay. So I simplified it to log 7 base e 2x plus 3.
So log 7 base e equals 2x plus 3, is that right?
Yeah.
That's it. And what's next?
You'd make it ln 7.
Yeah. 7.
And then could you solve that in the calculator?
You need to keep this to an exact value.
What do you mean by exact value?
So you keep it as exactly ln 7.
Okay. So can we divide it by 2x plus 3 on both sides?
You would subtract 3 first.
But then it wouldn't be ln 7.
You could write it as, let's say, minus 3 plus ln 7.
Oh, okay. Could you then minus ln 7 on both sides?
You want x by itself?
So you divide by 2 on both sides.
Yeah.
But that would change ln 7 to ln 3.5.
No, doesn't work that way.
Oh,
I would do something like minus 3 over 2 plus a half ln 7.
okay. Okay.
No, they want the exact form, so that's it exactly.
Oh, is that the answer?
Yeah.
Okay.
Let's see. So they get a bit different. Okay. Let's see. Okay. All right. We'll try the other one now. Part B.
Okay. Would you turn that back into log?
Yeah.
So it'd be log base x 3. Wait, what would that be right? Log 3 base x.
Well, let's just say it's ln is log base e,
Okay.
and then just go from there. Put it into power form.
Wait, so would you divide by log e on both sides?
you would put it as in the reverse of this one. So this is the base, this is the power. So like e cubed equals x. So before I had it with the arrows, like in that type of thing.
Oh, okay. Okay.
Yeah. So ln is just log to base e.
Okay.
Okay, let's try this one. Question B.
Wait, so which one am I doing? B, or which one am I doing?
B, yeah.
Okay, cool. Okay. So I reverted it to 2 log x base 3 plus 1 equals 5.
Base e, is it?
Yeah.
Yeah. And what's next?
And then it would become 2 log 1 e to the 5.
I would subtract 1 first.
Okay, so you get log ex equals 4.
Yeah, and don't forget the 2 at the front.
Yep. And then it'd become 2 log e, and then base e to the 4.
It has to be just log, not anything else. So you'd have to get rid of the 2 as well.
So you divide by 2 on both sides.
Yeah.
Which gives you 2 on the right, so it'd be log and then e to e squared.
Oh, you're always... Yeah, e squared.
Equals x.
Yeah. So it's exactly e squared. Great. So that's ln. And what is this ln? 3 plus ln. Yeah. Any idea how we would do this one?
Okay. No.
The exact coordinates of A, I believe for the A coordinate, y would be, sorry, x would be 0.
Okay. So you make x 0 in the equation.
Yeah.
So it'd be just be 4 then. Ln 4.
Yeah. So y equals?
So y equals 3 plus log 4
Just
base e.
just ln 4 is fine.
Okay. Wait, how come there's no... Oh, is that the answer?
Yeah, so I think as a coordinate it would be 0, 3 plus ln 4.
Okay.
And then part B would be the coordinates of B. Any idea how you do that one?
Would you make it log 4 base e first?
Well, for this one, x is 0. For B,
X is a number. It can't be 0.
y is 0. On the x-axis, all the y coordinate is 0.
So it'd be 0 equals
Yeah.
3 plus ln 4 minus x.
Yeah.
And then would you...
So this one will be more similar to what we were doing.
Would you make it log, the ln?
This one, yeah, you do the whole log thing, yeah.
So it'd be log 4 minus x base e.
Yeah.
then could you minus 3 on both sides?
Yeah, well done.
Which gives you minus 3 equals log 4 minus x base e.
Yeah.
And then could you solve the right in the calculator?
No, exact coordinates. So you would do the... I could write equals minus 3 on the right side. That's usually the way we have it.
Okay.
We want now to eliminate log to have it in the exponential form.
So do we make it ln?
No, we do. I use these arrows, but don't get confused.
Oh wait, you bring it to the right, so would you make it equal to 4 minus x and minus 3 would be on the left?
Yeah. So
Would it be minus 3 to the power of e?
e to the minus 3.
Okay.
Yeah, e to the minus 3.
And then we can add 4 to both sides.
Yeah.
Which gives you...
Subtract 4.
Oh yeah, subtract. E to the minus 3 minus 4 equals minus x.
Yeah.
Well, and then you can solve what e to the minus 3 is?
No. Times both sides by minus 1.
Minus 1.
Mm-hmm.
Which gives you e to the minus 4.
So it will give us like x equals.
X, yeah.
And then these two would swap basically. So it would be like minus e to the minus 3 plus 4, which is the same as 4 minus e to the minus 3.
Okay.
Yeah, so it's just solving it. And so that's the, what is it? That's the y coordinate is 0. And so what would that one be as coordinates?
4 minus e to the minus 3 comma 0.
Yeah. Well done. 4 minus e to the minus 3, 0. And then the other one was 0, 3 plus ln 4. That's great. Let's see. This one's very similar. Yeah. There was one type that was different, I think. And it's this part C type. Any idea how you do part C?
Okay. Would you make e to the x u?
Well done.
Okay.
And what would it become?
Would that be e squared?
No.
Sorry, u squared.
Yeah.
Plus 5u. And then you'd minus 14 on both sides, giving you minus 14 equals 0.
Well done. And then you just solve it.
Yeah,
I didn't realize it would be so similar. So how about this one? Yeah. Any idea how this one works?
Okay. So would you make e to the power of x u?
Yeah. What you could do, if that was u. So what is this one?
Would that be u to the minus 1?
Yeah. So u plus 12u to the minus 1 minus 7 equals 0. And any idea how you solve that?
Would you write it out as 1 over u?
You could write it as 12 over u because you have the 12, like times 12. But any idea how you solve that?
No.
Times everything by u. What do you get?
U squared. Would it be plus 12 over u squared?
It would be plus 12u over u.
Okay. Oh, so it'd be u squared minus 7u plus 12
Yes.
equals 0.
And then it's just normal from there.
Yeah.
So to the minus, you just multiply everything by the denominator, and it
Yep.
becomes okay. Any idea about this one?
Okay. So would you let e to the x be u?
There's a kind of a trick to this one, I think. Okay. So u minus 12. And what is this one then?
Would it be u to the half?
Yeah. And I just brought it to this side. So any idea how we solve it if it's like this?
Okay. No.
The easiest way is to always make the lowest one equal to it. So let e to the half be equal to u. Sorry, let e to the half, like x over 2, be equal to u.
Okay. So it'd be
Let e... I'm just trying to think. Yeah, e to the x over 2 be equal to u. So that becomes u. That becomes u. That's still minus 12. This one, any idea about this one? That is e. You
I
could do
don't
that.
know. Would it be over 2? Yeah.
It's like that. Yeah.
Yeah.
And so it's u squared. Yeah, that's a common one. But it's tricky. Okay, so to the half, let it to be the smallest one, and then that one becomes
So would it
squared.
be u squared minus u minus 12 equals 0?
Yeah.
Okay.
And then you'd solve that one. So those ones are okay. Let me see this one. Solve this. Any idea how we solve this?
No.
So they took ln of both sides. Ln 3 to the x e to the 4x minus 1 equals ln 5. So instead of log both, so x is in the power, so you have to do logs.
Yeah.
And there's an e, so you do a special type of log, which is ln, base e.
Yeah.
Ln of something times something. Rules of logs is that means they are added to each other.
Okay.
Okay. How would you go about solving this one?
So they're added to each other?
That's the same thing. If they're being multiplied by each other, that's when power index times index, you add the powers. These are just the powers,
Okay.
a different way.
So then would you make them log?
Bring
Log base e?
yeah, I'd bring the powers down first.
Okay. So would the powers be, would it be ln 3 base x?
X ln 3.
Okay. And then it'd be 4x minus 1 ln e.
Yeah.
Equals ln 5.
Yes, and let's see, ln 5, sorry, ln e.
Yep.
I just have to do it as e to the 1.
Yep.
And it gives you 1. And it's because ln e, log e base e, it's to its own base.
Okay.
So that's just times 1. So that's just 4x minus 1. And what's next?
That would become x log 3 base e.
Let's leave it as ln, because this is
Okay.
ln over here.
And then
Yeah.
could you minus ln 5 on both sides?
I would add 1. So send the numbers to that side.
Which would give you ln 5 plus 1.
Yeah, I'll write it as 1 plus ln 5 so we don't accidentally say ln 6.
Okay.
And what's next?
Wouldn't it be 4x?
Yeah, sorry.
Yeah.
And any idea what's next?
No.
Factorize the x.
Oh yeah, so it'd be ln 3 plus 4.
Yeah,
And then you divide by ln 3 plus 4 on both sides.
yeah.
So would that be the answer then? 1 plus ln 5 over 4 plus ln 3.
Yeah, I just wrote it. I swapped them around for them because they wanted the number first. Yeah, it's good to put the number first and the.
Yeah.
1 plus ln 5, 4 plus ln 3. So it's similar to the other one. If you see two things in a logarithm being multiplied, laws of logs, you can bring them apart. They're adding. If they're adding, you multiply. And it seems. So that one's similar to that one. Yeah, very similar. Let me see.
Yeah.
Logarithms and non-linear data. What is this for? So that's the last thing. Logarithms. Yeah. So it's basically modeling using logs.
Yeah.
But we got it. I think we got it. Yes. And so, what do you give yourself for that one?
Probably between a tick and a half.
And so, yeah. How was that for you, Adam?
That was good.
And so I think we're on to stats and stuff for next time. Any questions for me in general?
No.
All right, well done, Adam. It was great.
Thank you.
I look forward to talking again next time.
You too. Bye.
Take care. Goodbye.